All right, y'all, we're back with Dylan, the rock star himself. Let's hear what he has to say about his bio in his own words.
So hey everyone, I'm Dylan. So I have this little bio on my website. It says, Dylan does interesting things with code, computers, comedy, music, and video, and then travels all over the world talking to people about it. Obviously, traveling around the world is on hold for a while, so I'm doing the rest, and I'm doing podcasts about it instead.
All right, so that's Dylan. Now, before we jump into the full conversation that I have with him, let's just give you a bit of an update, news flash, whatever it is. If this is your first time watching or listening to the Are You a Robot podcast, videocast, whatever you want to call it, however you listen to it, I will let you know what we are doing here. And the whole theme of this podcast or videocast is that we bring up issues that stem from AI and related technologies, and we discuss them in depth. We bring on some of the best and brightest minds in the field to talk to us about what they are doing on the cutting edge or how they are viewing the world. We want to create some kind of best practices as we move forward, and AI and machine learning and all of these different technologies become or continue to become more and more a part of our lives. So we have this videocast. We also have a Slack community that I would encourage you to jump into if you are not in it already. It is a wonderful place where many, many bright minds, a lot brighter than myself, are talking about what they're working on, how they're viewing things. And it's wonderful because we get to see some of the past guests interact with each other, and also we continue the conversation. What we have been talking about on here continues in this Slack community, and we make sure to bring up some of these issues and get your opinion. If you have something or a strong opinion around what we are talking about, we would love to hear it and see what you think. That was a long-winded way of saying get into the Slack community, check out the links below. Last thing I will mention before we jump into the conversation is that there is a wonderful sponsor that is behind all of this. EthicsGrade is an ESG benchmarking firm, and they specialize in technological benchmarking. If you want to know more about them, you can check out the links below, but I have to say thank you from the bottom of my heart, because if it wasn't for them, we wouldn't have the caliber of guests that are on here, and we just wouldn't be here in general. Let's face it, they're awesome. They're doing some really cool things. Check them out. Now, without further ado, let's talk with Dylan.
Are you a robot?
Thank you for joining me today, Dylan. I really appreciate it, man. This is going to be exciting.
I'm looking forward to it, man. It's good to be here.
Yeah, and now let's just break things down a little bit, because you have so much that I want to get into. You are a rock star in more ways than one, and you have been known to be a,
Actually, I'd argue that what I am not a rock star in more ways than one, because what I sort of semi-consciously tried to do is to take this whole daft thing about rockstar developers and come up with as many ways of undermining that by qualifying for it in various ways. I'm a big music fan, and I know a great deal about what life is actually like for real, professional entertainers who spend the year on the road and sell millions of records. This is not that. They do their thing, and I love and admire them for it. But as an industry, we talk about rockstar developers. I'm like, well, what if there was a programming language called Rockstar? What if there was a developer who played the guitar? What would that do? How would you, put that in your LinkedIn keyword search?
I love it, man. Well, I know there's a lot of places that you've already talked about the road to building the Rockstar language that we are going to get into a little bit, but maybe you could give us a bit of background, the short, unabridged version.
background on the language or on me?
On the language, sorry. Yeah, and how it came to be.
So it starts, the trope of the Rockstar developer is old. That goes back, decades. And there's a Scott Hanselman blog post about, the myth of the Rockstar programmer, which I think is about 2013. And it was a joke that Paul Stovell put on Twitter about, to really confuse recruiters, somebody should make a programming language called Rockstar. And I thought this was a great idea. And, as being the internet, I'm like, oh, somebody's going to do that. And, a couple of weeks later, nobody had done it yet. And I was in a bar, I had my laptop, I had a beer, the people I was meeting, they were running late. And it just, one of those moments when you're like, maybe I could try and write a joke specification. And it started out, you take that kind of very dry style that language specifications use. And I'm like, I wonder how many heavy metal jokes we can fit into one of those. I came up with a spec and I put it on GitHub and lots of people started it and liked it. And then someone implemented it. And I was like, no, that's not how this was supposed to go. And this little kind of, community sprung up around it of, programming language and esoteric language enthusiasts who were like, this is actually a really fun idea. And, it was never intended to be a real thing, but I kind of wanted to put enough attention to detail into the joke that it would at least, read plausible and consistent. And it turned out that 90% of what I came up with as a joke in a bar was actually implementable in a formal grammar for a programming language.
Which is incredible.
We had to tweak a couple of details on the spec and stuff, but most of it, was kind of implementable straight out of the gate. And then, out of that came a reference implementation, and I built my own Rockstar compiler Rockstar interpreter in JavaScript, which I put online at codewithrockstar.com so that anybody who wants to can go and play around with it without having to install a Scala runtime or anything. And now it just it's one of those little things that lives on the internet, and sometimes people who've not seen it before find it and go, this is so cool, and I get random email from them maybe 2-3 times a month, which is kind of nice.
So I think the most ironic part of this is that by doing that, it's enabled you to live a bit more of a rock star life, and you get to go and travel around and give talks. So you've you've incepted this whole idea into existence.
Oh, it's got, levels upon levels of being kind of self-referential. And, people are like, well, what is it? Is it a real language, or is it a joke, or is it a music project, or is it art? And I'm like, it can be all of these things, depending how you look at it. There is certainly an element to it which is whimsical, and there is an element to it which is thought-provoking, and there's an element to it which is genuinely being on a stage with a guitar in front of a couple of hundred people who are all having a good time. These things are all simultaneously true. And on some level, they sort of like, it's a rock concert about programming. What is this? Really a thing? It's like, well, the people in the room seem to be enjoying it. So, I guess it must be,
Because for those who don't know, I may have jumped over this, but you get to travel around and you give concerts and you talk about programming, but you have a programming language that when you read the programming language, it is verses from songs. So it reads like as if it were a song lyric.
Yeah. That's the whole idea. Is you take, programming is about, you look at different mainstream language, any languages, any kind of established programming language, and you take there are the fundamental operations like string concatenation and adding two integers and flow control, if else statements, and you get into Lisps and things, you get some more advanced symbol types and macros and all these kinds of concepts, but fundamentally programming languages are a way of taking these concepts and translating them into an expression where a human being feels confident and expressive using that grammar to tell the machine what they want it to do.
Yeah.
And you can do anything, anything you can write. If you follow some rules and some structure around the grammar, you can, in theory, create a programming language that resembles that kind of written material. So, I've talked in talks before about Chef, which is the programming language where the programs look like recipes. And, there's LOL code, which is like the lolcat language. And there's one, is there an Arnold Schwarzenegger programming language where all the language statements are quotes from Arnie films? And so, you go mining because rock and roll and heavy metal lyrics, they have some well-worn tropes about, writing songs about, true love and broken hearts and all these kind of cliches. There's this old quote, someone said, telling a programmer that there's already a framework to do something is like telling a songwriter there's already a song about love. It's not going to stop them doing another one. And I'm like, well, what if there was a song about frameworks? Let's take love out of the question for a moment.
Oh, it's brilliant.
And so, I sort of started looking at it and thinking, how can you take recurring motifs from the lyrics of rock and metal music and create a grammar which allows you to use those as parts of a computer program? And it turns out you can do everything. It's Turing complete. Now has array types and all these kinds of things have been added to the language over the years. And it still looks like bad Meatloaf lyrics. So
there's something you said there that I would love to get into more about Turing complete. And as we move into the whole ethics conversation of this, can you break down what Turing complete is real fast for those of us that don't know?
So Turing completeness is basically there is a category of problems which can be decided by a computer. There are problems which are computable and there are problems which are not computable. And it was Alan Turing he created a hypothetical thing called a universal Turing machine, which is, I don't know if you've ever come across this. It's a stack machine. It's got an infinitely long paper tape. And every position on this tape can have a 1 or a 0, true or false, written into it. And then you have a state machine, which has to encode a set of instructions which say, you can move left on the tape, you can move right, you can write a 1 in the current position, or you can write a 0. And what Turing proved is that every single possible computer can be emulated on a universal Turing machine. So in terms of the set of problems that they are capable of solving, all programming languages that are, capable of solving the set of problems are equivalent to a Turing machine. And so if your computer can solve all the problems that a Turing machine can solve, then your computer or your language is Turing complete. Just let me mute something here. 1 second.
Yeah.
There we go. This is the year when everything that ever happens has little Slack notification noises popping up in the background from time to time.
Exactly.
And it's people are often like, everything's Turing complete. PostScript is Turing complete. CSS is Turing complete. Excel is Turing complete. And yet, they are. If you are prepared to be imaginative enough in how you construct them, then you can use PostScript, or you can use the C preprocessor macro language to solve any problem which can be solved by a computer program. And so, that's what the notion of Turing completeness comes from.
So let's dive into language itself and how you've built a language, this Rockstar language. And I think that this idea of Turing complete is, how can I put my words on this? If you had, so I'm just, kind of going into the future, and we are now, what most people are trying to do is say that it's possible for AI to be, conscious. And that's what a lot of people are trying to get to. I have my doubts, but it is something that maybe it's not going to be in my lifetime, or maybe it's in 2,000 more years if we make it that long. But I'm wondering, when I look at language, and there's a great TED talk on this about, man, I know from my own experience, when I've learned a new language, it changes how I see the world. It changes the way that I relate with people, and it almost gives me a different aspect in my personality and in the way that I interact. And so I just think about these programming languages, and if you think about what a computer that is, the sci-fi, what we're trying to go for, like her, or a computer that is conscious, I'm wondering, will it matter what language it was written in? Do you follow me on that?
So, and yeah, I think so. And there's an interesting kind of angle to dig first into the whole notion of machine consciousness. There's a very famous quote, which was, and I'm probably going to massacre the pronunciation of his name now, Edgar Dijkstra, who said, the asking whether a machine can think is like asking whether a submarine can swim. And, that I think there's a lot of kind of subtlety in that, because, submarines definitely can travel through water, but we would never attribute what they were doing as swimming. We have a different word for that. And so when you start talking about the notion of machine consciousness, kind of computer think, it's like, well, look at the number of cognitive processes that human beings lump together under the umbrella term of thinking. You've got, how much is it? I think it's about $85.
Yeah.
I think it's over there on the left. I think Jimi Hendrix was massively overrated. I think maybe I love you. These are not the same thing that is going on, but we call it think because it's something a brain did. And so almost our definition of thinking is what brains do. If a brain does it, it's thinking. And if a computer does it, it's not thinking, because thinking is for brains. And it's like, well, no, come on. Can we explore this idea around consciousness a little further? And there's a great book by Roger Penrose. It's called The Emperor's New Mind, where he's talking about different models of consciousness. And he comes up with these four potential outcomes of the sort of evolution of machine consciousness. One is it's impossible. And, all computers and analytical processes, they will always be completely deterministic other than randomness. We'll never get any kind of emergent behavior. The second is we'll get to a point where we can replicate it so well we can't tell the difference, but it's not actually true awareness. The third is that machinery will develop a form of consciousness and self-awareness that is directly the same as what goes on in the human brain. And the fourth is that machine consciousness will be a different kind of awareness. I sort of think about that quite a lot when people talk about machine learning and convolutional neural networks, and this whole idea of, well, at what point is you get a neural net that starts exhibiting behavior you don't understand. And at that point it's like, well, what did we train it on? Where did it learn to do these things? Let's look at the training data sets that went into this convolutional model we've created. And then, you do get into, if you program a computer so when you type in, "Are you conscious?" it says yes. Do you believe it? And at what point is that going to become an ethical question as opposed to a scientific one? Because it's, whatever the answer to that question is, I do believe there is going to be a point where that is no longer a sort of hypothetical. And the whole, machine learning and this kind of stuff, they love hypothetical problems. The trolley bus problem. Should we program a self-driving car to avoid a pedestrian and kill another one, and what factors? And, I have a driver's license, and they didn't ask me that on the test. They just kind of said, all right, we think you know what you're doing. When it happens, if it goes wrong, we'll arrest you and take you to court and figure it out.
Yeah, they barely wanted to know if you could parallel park.
Yeah. And so, you have these, it's very easy to get derailed, excuse the pun, by the hypothetical questions, when, the reality of self-driving cars is, well, they might kill one or two people, but they're going to put tens, hundreds of thousands of truck drivers out of work. That's a real problem. What are the sociological and ethical implications around that? And, a self-driving truck probably doesn't need to be all that smart to deliver cargo reliably on empty streets in the middle of the night when there's not a whole bunch of other people around. At what point do we as a society accept the risk,
These are great points. These are very good points.
And to go back to, so you sort of moved on from that to talking about language and the way that kind of language informs the way you think. Now, I really only speak English, but I can read Russian. I know the Russian alphabet, and it's often interesting to me how, there are certain words that if you, as an English speaker, are traveling in, Russia and Eastern Europe and Ukraine, the words translated into English look really, really complicated because we don't really have the alphabet necessary to spell them properly. And so once you learn to read them in Russian, you're like, well, здравствуйте, okay, that's not that big a deal, And there's a thing I've mentioned in a couple of talks. We have this colloquialism in London in British English where you go into a bar and you order the usual, and then this gets shortened to the usual. And huge is a word it is impossible to spell in British English because we don't have an unambiguous way of writing those sounds. But the Russian alphabet does. They have a U and they have a J. So in Russian, huge is unambiguous. And there's occasionally moments where I'm like, can I just use a different alphabet to write this one word so people will pronounce it properly? And yeah, I have had friends of mine who speak English as a second or third language say, I wish you knew me in Norwegian. I'm really funny in Norwegian. And I think that's actually really sad. Like, there's a whole aspect of your personality that I will never, ever appreciate because I can't understand, and it gets you into this idea of language as a, both as a conduit and as a barrier. There's a language barrier. Yeah. It's like, it doesn't matter how profound somebody's insight is if you don't understand the language in which they're expressing it. And that kind of comes around to the idea of programming languages and languages which make certain kinds of concepts very, very easy and intuitive. Pattern matching in functional languages has proved influential enough that there's now a, move to try and get some similar constructs in a lot of more procedural or object-oriented languages. And, I'm from the .NET ecosystem, so most of the really cool stuff in .NET starts out in F#, and if it's a good idea and it gets a bit of traction, it makes it into C# a couple of versions later. And so that's an interesting place to look at how the grammar and the structures used in programming kind of inform the way that programmers start thinking about solving problems.
Yeah, I think there's two things I wanted to mention on what you're talking about. And one is this idea of feeling like, oh, I'm funny in my other language. And I noticed with myself when I was learning Portuguese, I didn't have the ability to be funny. And I tried, and I felt like there was a big breakthrough one night when it wasn't that I made a joke, it was that I understood a joke. And then it was like, oh man, I'm getting this. And it's that little like gratification, like, okay, what I'm doing is paying off. And what I would argue is that, yeah, like you were talking about that barrier, it's when you don't have the proper mastery of the language yet, you can't get all of your personality that is like, you just can't transmit your whole personality in a way. And the other thing that I wanted to mention to you and see your thoughts on was the whole idea of, and I'm sure you've heard about the, GTP or GPT-3?
GPT-3, yeah.
Yeah, I always mix those letters up. It's not the easiest thing to say, but for those who don't know what it is, it's a machine learning algorithm, and you can do a lot of things with it. One person has made it so you can create a web page by just typing in plain English into a little box, search box or a text box, and then it will create whatever you say. So you see like videos on the internet where it says create a watermelon with 5 seeds, and then it will draw that. And I heard a great argument on this where people, because obviously a lot of people were saying, oh, this is the end of coding. We don't need to know how to code. We can just talk into this algorithm and it will create what we want or whatever web page we want, right? And the thing is, though, that I find fascinating is that with the coding languages, what makes it so effective is that you do have barriers and constructs. And with like us in English just talking into or writing our normal everyday English into a text box, there's so many ways that we can put the same thing, right? But when you're using it in a programming language, it's this way because you're writing in this language. And so you have this certain set of constructs. So I wanted to hear your thoughts on that, and if you think that it is the end of programming, or you still are confident that there's going to be programming languages out there.
I do not believe for 1 second that GPT-3 is going to render the human craft of software development obsolete anytime soon. I mean, I think the GPT-3 is really interesting because I've been trying to get on their beta program for a while, and I think they keep turning me down because I've told them that I want to use it to generate heavy metal lyrics, and that's probably not what it's supposed to be used for. But what it does is it generates it generates bullshit. And if you've ever dealt with anybody like the President of the United States, who is still Donald Trump at the time of recording, but that could change at any point this afternoon. Or, there's certain kind of consultants or financiers or business people. There is definitely a skill to picking up enough terminology from the domain you are supposed to be talking about and putting it back together in a way that somebody who is not a subject matter expert will think you know what you're doing. I know nothing about cars, but if I said something, and I'm just stringing words together, if I said, the timing voltage on the carburetor is underneath by 0.2, which means you're probably going to get a little bit of reverse diff lock, somebody else who doesn't know anything about cars would be like, wow, this person must know a lot about cars because they used all of these technical terms in a very confident way. And that's most people. And people who do know anything about cars are going to be like, this guy is so full of crap, who gave him a microphone, And I think, you look at GPT-3 and it generates very plausible sounding, and obviously elements of it have been just kind of distilled and it's paraphrased things, and it's plausible, and it reads like somebody who has stayed up late writing an essay that they've not done the research for. And so they're just like, I'm going to come up with something that's the right length and
Absolute
it has sentences and it hangs together. And hopefully, I'll get lucky on some of it and the professor won't check the rest too closely and I'll get a pass grade on it. And, as we've established through centuries of students qualifying and getting degrees in college, that is a perfectly valid communication style for a very, very specific scenario. And if your website is your hand carving, cat figurines out of avocado stones, and you want a thing that here's the story of artisan craft. Yeah, it doesn't matter if that's bullshit or not. Yes, I absolutely believe that for selling crystals and homeopathic remedies, GPT-3 will be able to generate your website for you, and it'll do just as good a job as if you'd hired a human to do it. But, then you get into the nuance of, what do you want? I want a mobile phone app that people can pay £5 for a picture of their face with cat ears on their head. And you're like, okay, let's take that. Now, at that point, you could give that brief to 100 programmers who would all come back with something that ticked all of the boxes on that list. What is it? It's a mobile phone app. What do you do? Oh, well, you use Apple Pay. You upload a photo with the camera. It draws the cat ears on your face just by laying over a transparent PNG. There you go. That's it. I've solved all the requirements. And you think about how many, 100 programmers, you ask them to do that, you're going to get 100 different apps. iPhone, Android, maybe Windows Phone, different image composition, different payment integrations, all these different kinds of things. And, you think if the person who has made this request honestly doesn't care, if they're just like, look, no, this is just all I need, this just anything that ticks the boxes, then yeah, maybe, GPT-3 will be able to be, all right, the machine learning model will understand the nouns and verbs in the sentence and can generate something that satisfies those requirements. But if you've ever worked in software, that there's two kinds of programmers. There's the ones who go, all right, they go away and build it, they bring it back, and the client says, that's not what we had in mind. or there's the programmers who, actually there's three kinds. There's the ones who go away and build the wrong thing. There's the ones who go away and they build the smallest possible prototype of the wrong thing and bring it back so they can find out what it's supposed to do. And there's the ones who are like, all right, now we need to do a requirements gathering exercise. And, I can maybe foresee a day when GPT-3 goes, all right, please specify what models of mobile phone you want to support. And the customer goes, well, good ones. And it's like, all right, is the Samsung Galaxy Note 9 good? And they go, I don't know. And it goes, well, you're the customer, you tell me. And you get down to a kind of, conversational interrogative model where eventually the product owner goes, you know what, I'm just going to talk to a person. It was much easier. And, I can maybe foresee that kind of thing happening at some point down the line. But, I don't think the whole thing, language and software and everything is so much of the challenge is that the person who is responsible for the requirement, the person who wants something to happen, they often have a picture in their own head that to them is perfectly clear because they haven't looked at any of the details.
Yeah.
And, quite often some of the greatest value you can bring to a software project is being the kind of person who can sit down with that stakeholder and be like, right, we need to figure out some details here and do it in a way that doesn't feel confrontational and, doesn't feel aggressive, but is like, okay, so let's talk about the frequent flyer miles program. So, you get a free bottle of champagne when you get to 5,000 miles. Is that right? And they're like, yeah. It's like, okay, do you want, because if we give them that at the airport on the way out, then do you want them drinking it on the plane? And they're like, no. It's like, well, if we give them to the airport when they get to their destination, they won't be allowed to take it on the plane coming home. Okay, I see the problem. So, and you get into these little details and, the art of software development, I've thought for a long time, is about that constant balancing act between, ignoring too many details and investing in the wrong solution, or exploring too many details and getting bogged down in decisions that actually don't matter yet. So.
Well, first of all, very impressive that you knew what my side business was with the crystal healing website. Second of all, as we look at this, for me, it makes complete sense that right now, what we have in this machine learning space, it's not good enough. And maybe there are these nuances that are needed, that it needs to be a back and forth. But I look at it as an augmenting of our abilities. And right now with the language, we can't augment it as much, as well. But with things like art, especially like pictures, and I have a friend, Dan Jeffries, who we've also had on here. He has created MIDI signals from ambient music. And actually, you'll love this story. And I'll give it, for those listening who already listened to Dan Jeffries, forgive me. I have to tell Dylan about this because he, as a fellow musician, is going to love this. So Dan Jeffries he had a machine learning algorithm, or he gave a machine learning algorithm a lot of data from ambient music. That was the data that he fed into the algorithm. It then spit out a bunch of MIDI signals, which were the basis for an ambient song. And then Dan was the one who got to choose what sounds to make the MIDI signals. So it was like there wasn't a full AI that said, here's your ambient song, right? It was like, hey, here's the MIDI signals, but then Dan is the one who actually has to be a human in the loop and say, okay, I want to put this really cool synthesizer as this MIDI signal. And then it's an amplification of Dan's creativity, right? And so I look at it like that, like supercharging the ability for us to be able to do things like that. And so I completely got a little bit lost on getting excited about that whole thing. And I wanted to ask you a question as far as like the amplification of it goes on. Oh yeah, that's where I wanted to go with, was in the video I watched of you that we'll link to below. It was where you gave the presentation on the art of code. And you showed artists that are doing things right now on computers and are working with this, like amplifying their abilities. And so I just wanted to hear you talk about that a little bit.
So there's a couple of things where I find this idea of using technology as a kind of to augment the process of human creativity is very, very interesting. And I think, we've been through the 1950s, 1960s, we realized that technology could do mathematical calculations faster than humans. And that's, if you watch the movie Hidden Figures, there's the great story about, the black female mathematicians who were working at NASA, and one of them became one of the first Fortran programmers. And so, at that point, it's like, well, okay, if we're just adding numbers together and doing calculations, machines can do it faster, better, more accurate. They don't get tired. That's obviously, something that it just makes sense to use machines to do that.
Yeah.
And, there's been this interesting kind of tension ever since. The movie Tron, which was 1982, which, very, very famously a lot of that movie was generated on computers. A thing called the Foonly One, which was a one-of-a-kind, image processing frame buffer supercomputer. And Disney paid for it, but then none of their animators would go near it because they're like, we are not working on a film that uses a computer. This is heresy. And it was disqualified from the Academy Awards for the same reason, because they said you're not allowed to use a computer to do a human job. And, you think at that point, if you have human animators making a movie, where does the artistic direction and input for that come from? Because you have the director, you have the script, you have the screenplay, you have the character designers, and then, you've got people working at places like Disney whose job was they would come in every day and they would paint animation cells. They didn't design Mickey Mouse. They could just paint him really, really well. And so they'd just sit and they'd paint Mickey 200 times a day for decades. That was their job. And I couldn't do that job. That's not a skill that I have, and possibly not a skill that I would be able to develop. But also, we reached a point where it's like, well, no, now that's kind of been now put in the same bucket as doing computations and calculations, because we can achieve the same output by doing it algorithmically instead of relying on a person to do the same thing over and over again. And then that kind of tipped the balance, and now, computers as part of digital filmmaking and animation is just established. That's, you look at any of the big Hollywood blockbusters from the last few years, there's CGI everywhere. And, that's sort of established. And, things like music production, it's, replacing magnetic tape with digital, nonlinear editing was a massive advance. But
well,
even
still I just think about, what is it, the phonogram?
Yeah.
Like, what I heard about with when Edison came out with that is people revolted. They were like, what is this? This is not music.
Yeah. No, it's his business model for the original. I mean, it was wax cylinders and then it was wax discs. Was that they wanted a way to record speeches the way that photographs could record portraits. The idea that recorded music, it's like, well, why would you record music? Of course, any household worthy of the name has a musician, and being able to play violin, flute, clarinet, all these kinds of instruments, they were something that people were supposed to do, and music had to be live. And it was one of the things about entertaining is you would have live musicians. Recorded music was regarded universally as, heretical. And there was the idea that you would have a library in your house of great speeches, and so you could sit down after dinner and listen to Lincoln giving the Gettysburg Address, or something comparable from whatever time period. And of course, it turns out recorded music was actually a really good idea. But there's really interesting, traces of that whole decision-making process. Because if you look at the legal and the technological history of recorded music, the copyright in you ever go to a movie and you see the THX sound, that big boom noise, they weren't allowed to copyright that unless they published a written score. So Ben Burt, who was the sound designer at Industrial Light and Magic, wrote this one page. I mean, it's the weirdest piece of music you've ever seen. But he had to write a written score so that they could publish it, because the copyright on a composition resides with the composer, which is independent of the copyright on the recording. And this crops up again and again now because, anything composed by Beethoven, say, is now in the public domain. Beethoven has been dead for a long, long time, so all of his compositions, you are free to pick up your guitar and interpret one of Beethoven's compositions, or Bach, or, Rodrigo, or whoever, and put it on YouTube. But if you're good enough, you're going to trip their algorithms, because your performance will be so close to that published by a professional orchestra that they will think it's a copyright violation. And this has got into this really weird gray area of, you take two really, really accomplished classical pianists. Actually, let's go with harpsichord, because the harpsichord is an interesting instrument because it does not have a huge amount of nuance, because it doesn't even have loud and soft. You just play it. And if you play something like Bach on a harpsichord, you're getting to almost a very kind of mathematically pure form of music recital. So it's entirely possible that two accomplished harpsichord players playing the same sheet music at the same tempo will produce a recording which is algorithmically indistinguishable from the other one. And so YouTube will think it's the same recording, and it'll think whoever got there first owns the copyright, and that the other one is an illegal pirated version thereof. And we have no frame of reference for dealing with this. The technology is enforcing the law, and the law is going, we never had to think about this before. We honestly don't know what to do here.
And along those lines, I also think about the idea of like the machines that are being used also, like you were saying, and how these days now you could technically just feed that sheet music into the computer, and then you get an output of whatever the computer says, and you program it in there, right? So, but also it's a very interesting path to go down of the ethical issues along the laws of copyright. And how we are looking at that, because if it is a machine that has created it, because we go back to Dan Jeffries' example, it's a machine that created it, kind of. I mean, Dan Jeffries is in the loop, but we can easily picture a time when there is no human in the loop, and you just feed it a bunch of data that is ambient music, and then it spits out more ambient music that it decided what was good. So who owns that? Is it the original data that it was trained on? Is it the person who put all of the data into the algorithm? Is it the person who created the algorithm itself? Like, who gets the copyright in that place? Or is that just like void of copyright?
Well, it's, there are two interesting ways to sort of frame the argument. One of them is to look at how you interpret the laws that currently exist. So there's a precedent here that I think is interesting, which is about photography, because certainly here in the UK, and I believe in the US as well, and various other places, the copyright in a photograph is owned by the photographer. And so, if someone goes out into the Himalayas and they take a photograph of Mount Everest at sunset, they own the picture. That's theirs. If you take a photograph of a person in the street, you own the photograph. And they have certain legal recourse to say that you use their likeness without permission. And there's a precedent that says, well, if someone is a public figure who's already, known to the public, then it's in the public interest to photograph them, which is how the paparazzi operates. But there was a photograph a couple of years ago that was a guy set up a photographer, set up a camera in the rainforest somewhere and left it there. And a monkey came along and pushed the shutter and took a selfie. And this won an award for Wildlife Photographer of the Year. And then a whole bunch of places reprinted it without permission because they were like, well, the monkey took the picture and the monkey has no legal rights. The monkey cannot be the copyright holder because it's a monkey. And the guy's like, no, but it was, my camera. And they're like, no, but the monkey pressed the shutter, which means the monkey is the agent that caused the photograph to be taken. And so that opens up interesting questions. Wildlife photography is very, very common now for people to set up camera traps and leave them outside overnight with, motion sensors. Which point, like, well, if a monkey pushing the shutter is taking the picture, what about a snow leopard who walks in front of the camera shutter? Is the leopard the photographer now? Did the leopard
Because it
know
trips
that,
the sensor.
And then you kind of flip this around. You're like, well, let's say, you think about like fractal and computer-generated art, where you have an algorithm that will generate an infinite level of detail, something like the Mandelbrot set. And then you have somebody who spends a couple of days digging through that on their computer and zooming in, and they find a part of it they think is beautiful, and they capture that. Now, at this point, there's an argument that says this is like landscape photography. Somebody has invested their time in going and exploring a, terrain, and they found a scene that they think is attractive, and they have captured that scene for posterity. But there's another argument that says, well, no, all of that was actually created by the person who wrote the algorithm. You doing that is like you sitting and watching a Star Wars movie and waiting for a scene you think is beautiful and then taking a screenshot and going, look, I made this picture. And they're like, how did you make the picture? You're like, oh, I watched Star Wars till it got to the good bit and then I made this picture from it. And it's like, well, that's clearly nonsense. The copyright in that frame is owned by Disney and Lucasfilm because they paid the people who made it in the first place. But, we're getting to a point where, like Peter Jackson's Lord of the Rings movies, they had an algorithm thing called Massive to orchestrate the battles. So they have these huge battle scenes, big sweeping overhead shots with cameras and, thousands of orcs and elves and everything. And none of that was hand animated. They were all software agents that were given priorities and behavior, and then they animated all of those characters algorithmically. And so, if you took a still from one of those things, who created the image that you're looking at? Because an animator created the algorithm, and then, Peter Jackson directed those scenes almost like a military general would direct a battle. It'd be like, right, 2,000 orcs over there, 2,000 elves over there, the orcs want to destroy that, the elves want to get over here, charge, go, bang, start the battle. And then it just kind of, and you're like, well, there was no single person who created those shots in a way that would be recognizable to the cinematographers and animators of the 1980s. But they also didn't happen spontaneously. There's a huge amount of effort and technology and creativity went into them.
Yeah.
And so, that's the one angle for looking at copyright and creativity is, well, what does the law say? And what have we done that moves it? And the other one is to kind of strip it right back and go, well, why does copyright exist in the first place? What was the fundamental premise of this idea that, we think people who... Because copyright is predominantly about creativity. It's about works of fiction, works of art, cinema, music, these kinds of things. It's not trademarks and it's not patents. And there is this idea that was enshrined in law that somebody who creates something, a work of art in the broadest possible sense of the word, they deserve to benefit from that. They deserve, if it's a painting, then you want to be able to control who can copy it and who can sell it. If it's a movie, you don't want someone taking a copy of your movie and playing it and keeping all the money for themselves, or selling it and saying, no, I made this movie. This is Star Wars by Dylan, age 8, whatever. And, you then sort of think, well, we now have a society where it would be possible to... create... So one, the cost of developing this stuff is coming down. It used to be you wanted to make a record, you needed $100,000 so you could hire a studio for long enough to get your band in there. Now you can make a record by yourself on your Mac in your spare time, and you can get pretty good results if you know what you're doing. And so, you make a record for nothing, but instead of $100,000 advance from the record company, you just make it and you put it out there on a platform that pays you every time it gets streamed. And, if we can guarantee that wherever that audio is used anywhere on the planet, you get a percentage, is ownership really the legal mechanism that is necessary to defend your right to benefit from your own creativity? And, at what point should it expire? Because this is another classic thing with copyright, and the Disney constantly extending it so that Mickey Mouse never ends up in the public domain. And it used to be, I think, 5 years after the creator's death, and then it was 20 years, and then 50 and 70, and And Tom Lehrer, the satirist and lyricist, he's just explicitly put all of his work in the public domain. He said, everything I ever wrote, he's in his 70s, 80s now, and he was like, nope, this is all free now, all of it. Everything I ever wrote, I don't want people fighting over it after I'm dead, and I'm getting a bit old, so it's all in the public domain explicitly now. You can do whatever you want with it. Take it.
That's
which I think is
incredible.
quite a nice gesture,
Yeah, it's like open sourcing your work.
Yeah.
So, going back to our language talk and looking at the word art, can we call something that a computer makes or an algorithm makes, can we call that art?
No. Because I think that the word art, in the sense that, certainly the only sense that I find it meaningful, is that it is something that was created by an artist. And that the artist has to be conscious. There must be because, there are displays of modern art now that I have seen in galleries that are, it's a pile of earth. Somebody has taken soil out of the ground and they have put it in a pile on the floor. And if you see that in any number of farmers' fields across the world, that is not art, because they did not put it there with the intention of creating an artwork. But if you do it in an art gallery, it's art because an artist did it. And I think that is the only definition which makes any kind of sense. And, it could be that the artist has meticulously sculpted their pile of earth, or it could be that they just threw it there out of a bucket blindfold. But either way, they are making a statement, and the fact that an artist did this on purpose means that it is art, and that which happens by mistake cannot be considered art, no matter how beautiful it is. Sunrise is not art unless you photograph it. Because the act of photography captures the intention. That's what I think.
Yeah, and that's so true. So it's like, unless there's intention behind it, which you feel a machine learning algorithm or a computer or whatever it is that we're feeding data into, unless that is devoid of intention. It doesn't have any intent behind it.
It doesn't happen spontaneously. Unless, you can build digital simulations that replicate spontaneity, but really what you're doing is you are putting in there some kind of random timeout or a delay, or you're waiting for some set of external constraints. We cannot create an algorithm yet that is going to sit there doing nothing for 4 hours and then suddenly get up and make something, unless we program it in 4 hours as a delay.
I see exactly what you mean. But humans, we can sit around on the couch and be doing absolutely nothing, and then all of a sudden an idea comes to us, and you grab the guitar or you go and you create. And
I literally, while we were talking on this part, I just wrote the word MIDI here on my hand to remind me of this, because I just had this idea of what would happen if you, so the notes of the musical scale, A, B, C, D, E, F, G, and I just thought, I wonder what would happen if you took a piece of text from a book, and you're like, all right, every time we see one of those notes, we're going to emit a MIDI note, and the length of the note is going to be how many letters we have to skip to get to the next musical note.
Oh.
And so you can take any piece of written text, and you can be like, right, turn that into music, and see what the melody of that piece of prose sounds like. And I love that kind of thing, because it's the sort of thing that is probably trivial to implement. Like, I can probably have a working implementation of that by the end of the afternoon. And then you get this interesting thing of, hey, the first line of Moby Dick sounds really, really good. Well, did I write that melody, or did Herman Melville write that melody?
And I even want to know, is that art? Because you were behind it, right? So now we can consider that art?
Well, that's, it's the interesting thing there, my intention as a creator there is I want to do an experiment and see if the outcome of that experiment is something that is aesthetically pleasing. So it's effectively, it's just like the photography example. It's like, I've just thought of an algorithm that will generate huge amounts of interesting material that I can then dig through looking for ones that I like. And so it's more of a kind of, it's like we've come up with a way of getting a machine to generate a random art gallery, and then I'm going to go through and I'm going to curate the exhibition.
Yeah. I almost look at it like you've just created a new musical instrument in a way. Someone can go through and they can bring their text. I could write a poem right now and then feed it into your new musical instrument, and it will spit out a song.
And there's the textophone.
There's the text. And so if we can get this working definition, if you do create it today, maybe we can have it as a little plug-in in the website when we launch this episode, and people can bring their text and they can see what your text sounds like. So I encourage you to check it out. If it is there, we'll add a little plug-in to the website or something. We'll do something, or just link to what you created.
Yeah.
And that is absolutely fascinating. I have one last question for you, and this has been an awesome conversation. I thank you so much.
It's been a lot of fun.
I want to know, are you a robot?
What would you expect me to say if I was?
I have no clue. No?
Yeah, I don't know.
I would expect you to say no if you were.
Well, no, of course not. But I tell you what, actually, I have 2 steel plates and 14 screws in my right leg from a skiing accident. So one, technically, I am not 100% biological. I have elements of machinery in my body. And 2, the rest of my body does not hurt as badly as my right leg does. So I'm pretty sure I'm not a robot, because the only bit of me that's metal reminds me every time it gets cold that it's supposed to be organic. But, who knows? Maybe we're all little biological nodes in a massive self-replicating von Neumann machine that somebody accidentally released on planet Earth 50,000 years ago. But
there you go. Exactly. Wow. Dylan, I can't thank you enough. This has been such an awesome conversation.
It's been my great pleasure. Thank you so much for having me on the show.
Yeah, and for everyone out there listening, we encourage you to jump into our Slack channel, where we are talking about more of these issues around AI ethics, AI governance, and just the future, what it may hold. We would love to hear your 2 cents on this. So check out the links below for a little bit of a introduction to our Slack, and we will see you all later.
Thanks, dude. Take it easy.